Hi guys, we are starting chapter 6. Hopefully everybody has had a good year and we are getting back into the swing of things. Alright, this is called the quadrilateral hierarchy. So the reason it's called that is because every shape on this picture is a quadrilateral, but some of them have special characters which make them then a kite, a parallelogram, a trapezoid, isosceles trapezoid, rectangle, rhombus, and square. We are going to go over each shape throughout our lessons this chapter, but today we are just going to remind ourselves what is the definition of a quadrilateral. Well, the definition of a quadrilateral is that it is a four-sided polygon. Okay? So any polygon with four sides is always going to be considered a quadrilateral. And the only thing that you need to remember specifically about just the quadrilateral is that it equals 360 degrees in the interior angle sum, meaning all the inside angles added together make 360 degrees. Okay, and that is it. That's all we are going to talk about today for the quadrilateral on the hierarchy. Let's go ahead and jump into 6.1 notes. All right, in 6.1 notes, we are talking about parallelogram properties today. So the learning intention is to learn special properties of parallelograms to solve for parallelograms. Okay, to define a parallelogram. So a parallelogram does have four sides and the interior angle sum is 360, so it is a quadrilateral. With two pairs of parallel sides. In a parallelogram, there are 5 qualities that you need to remember to help you solve for the interior angles and sides. So the important properties of a parallelogram, well, number 1 is the definition. That opposite sides are parallel. Okay? And if you remember how we mark that with arrows. So the top is parallel to the bottom, so they only get 1, and then the left is parallel to the right, so they get 2 arrows. Okay? The second property for a parallelogram is that opposite sides are congruent. So if you remember, if something is congruent, they get tick marks. Okay? So again, the top is congruent to the bottom, so I'm going to give them 1 tick mark, and then the left is congruent to the right, so they get 2 tick marks. All right? The third thing is that opposite angles are congruent. And if you guys remember, if angles are congruent, they get arc marks, which are those semicircle looking things. So the top left corner is congruent to the bottom right corner, and the top right corner is congruent to the bottom left corner. Okay, the fourth thing is that consecutive angles equal 180 degrees. Consecutive means beside, or next to. Same thing as adjacent, but we use consecutive quite often in this chapter, so make sure you're familiar with consecutive, next to. So the beside angles, anything that's beside, so the top and the bottom, they equal 180 degrees. The top left and the top right are 180. These two are 180, and the bottom two are 180. So as long as they're next to each other, they do equal 180 degrees. And the last thing is that the diagonals bisect each other, which then makes alternate interior angles. Okay? So with that, make sure you're using your geometers so we get our straight lines. We are going to draw our two diagonals. Bisect means to cut in half. So if a segment is cut in half, that means that it's split perfectly into two segments. So this diagonal from the top left to the bottom right gets split in half, which means that these are now congruent. And the same goes for the other diagonal from the bottom left to the top right. It is split in half. It doesn't equal, it's longer than the other diagonal, so it gets 4 tick marks instead of the others. Okay, these are the properties of a parallelogram. I am going to start putting in just some random numbers so you can see how all of these properties come into play. Just a reminder that the diagonals not only bisect each other, but they also create alternate interior angles. So I'm going to say that this is 25 degrees. And I'm also going to say that this is 35 degrees. And then I'm going to say that this is 20. And I'm going to tell you that this length is 5. This length is 7, and just for the sake of things, I know it's not completely accurate, but let's say this length is 6, or let's go 8, and this length is 12. And then I would ask you, okay, I need you to solve everything else in this shape. So we have a lot to figure out. Well, something that I know is that I have alternate interior angles. So this 25 is also equal to the bottom right, this corner. And this 35 is equal to this side of the angle. Then if I go searching over here to the 20 degrees, then I can say, oh, I know that that's alternate interior angles. And then we have this triangle right here. If you all can see it, well, triangles equal 180 degrees. So that's something that's super important as we are going through this section, is that if I have the 180 degree triangle and I subtract the two things inside the triangle, so if you see I have 20 degrees and I have 25 degrees. Well, what is that going to give me, guys? It's going to give me 135. So I know that this is 135. And then if we use our skills from what we have known in the similar chapters, that I have vertical angles and a linear pair. So this vertical is going to be 135 degrees. And then I know that I have a linear pair, which is 180. So I could take 180 minus 135 to get 45 degrees, which then tells me this is 45 degrees. And then I can use my triangle angle sum again. So I know that triangles are 180. And then I could subtract my two numbers, 35 and 45. To find that top angle, which if you guys do that in your calculator, I'm going to give you just a second. It is going to tell me that it's 100. And then I have alternate interior angles, so this is also 100. Okay. This length was 7, so I know that this length is 7 because they share the same tick marks. This was 5, so I know that this was 5 because they share the same tick marks. This was 12, so I know that this length is 12 because they share the same tick marks. And last, this was 8, so I know that this is 8. That is a parallelogram. It is a lot, but as we get used to these, you're going to realize that they go fairly quickly. You just need to figure out which part of the properties you need to solve for the parallelogram. Okay. Let's jump into just like something that's similar. So this is just asking us to use one or more of the properties from above. So notice I don't have any diagonals in number 1. Okay. The examples, directions say find the missing angles or variables in each parallelogram using the properties above. If you notice, I don't have any tick marks on my sides. I have nothing on the sides. So I don't care about if they're parallel or if they are congruent because I already know it's a parallelogram. But I do have angles. So if you look, number 3, it says opposite angles are congruent arc marks. So I know it's a parallelogram, so I know these opposite angles are congruent. And I also know in angles that consecutive next to angles equal 180 degrees. So I know that these are 180. And I know that these are 180. I know everything's 180 as long as it's next to, right? Okay, the easy thing is that I should see that, oh, Z and 62 have the same marking, so I know it's 62 degrees. And then the second thing is I'm like, oh, Y and 62, they equal 180. So I could find Y by taking 180 minus 62, and I'm going to get 118 degrees. And then I see, oh, Y and X, they have the same arc mark, so I know they are equal, so that is 118 degrees. And then you're done. Okay, you're just filling out the picture for the variables that are missing. Let's hop over to number 2 here. I see, oh, I have a lot of diagonals, right? So the diagonals, there we go, we read property 5. They not only bisect each other, but they make alternate interior angles. So if we're going to mark all that, let's go ahead and mark it. So I know Y is congruent to Z. I know 50 is congruent to the other side of Z. I know X is congruent to 33. And I know 70 is congruent to the other side of Z, or X. Something like that, right? Okay. Anything that shares the same markings with a variable and a number already existent, you can go ahead and fill in. So if you see, like this is 33, X and 33 have the same arc mark, so I know that X is 33. I also know that 70, even though there's not a variable there, it could help me out. So I know that that side's 70. The opposite side of Z is 50. And then I really start to think, like, how am I going to find the rest of this? And I need to look at my triangles. So if you look at specific triangles, you're going to start to notice that some of them already have 2 numbers in them. There's one. Okay. I know triangles are 180 degrees, so I'm going to subtract the 2 numbers already in there, right? So 70 and 50, which gives me 60. So this is 60 degrees. And then I have vertical angles, which is great. So then I know this side is 60. And then I also have a linear pair with W and 60. And so if you guys remember, a linear pair is 180 degrees. And we subtract 60 from that. And it does give me 120. So W is 120. And then W has its own vertical angle, which is up here, which is 120. Okay, I think I have enough information to find everything else, which I'm missing Y and Z. So if I use this triangle to find Z, I know that triangles are 180 degrees, and I'm going to subtract 120 and 33, and it gets me 27. So Z is 27. And then I know that Z and Y have the same arc mark, so they are going to be equal, so Y is 27 degrees as well. Okay, and that's how we solve for parallelograms that have alternate interior angles. We use those triangles equal 180 and vertical angle and linear pairs in the center to help us. Let's go ahead and look at number 3. If you notice, number 3 doesn't have anything with the sides again. Like, I don't have anything, but I do have angles, no diagonals though. So we're just going to mark the properties that's true about angles, which are number 3 and 4, right? Opposite angles are congruent, and consecutive angles equal 180. Okay, we have two options here. We can go ahead and use the 180 rule, or we can use the opposite sides are equal, or angles are equal. The important thing to know is that you can't put two variables together. So I can't use the 16x and this y off the bat, and I can't use y and 2x off the bat, or y and 3x minus 10 off the bat either, because one of them has an x and the other has a y. So since I know I can't use anything that has similar variables or opposite variables, I'm going to use the things that do have similar variables. So if you notice, these two guys have the same arc mark, and they both share the same variable, which is x. So since they have the same arc mark, that means they are equal. So since they are equal, we can make that a math equation. 3x minus 10 equals 2x. And then we solve that. So we're just going to subtract 3x. We get negative 10 is equal to negative 1x. And then it's negative 1, so we need to divide by negative 1. So 10 is equal to x. All right, now I have my x variable, which is great. To find the y variable, if you notice, these two have the same arc mark, right? So if I could figure out what that one is in degrees, then I could figure out y. I know it's 16x. So x is 10. If I plug that in, that's 16 times 10, which is 160. Since that's 160, then I can say, well, y is 160. And I'm done. Okay. These are more math equations because they're expressions that we have to put together to make an equation and then solve. It's not just as simple as doing 180 minus things anymore, but we need to set up our equation and then substitute in. Let's jump to number 4. Number 4, what do you notice? What you should notice is that there's no angles represented in this parallelogram, but there are sides represented and diagonals. So we need to mark everything that's true about the sides and the diagonals, okay? Well, what's true is that opposite sides are equal. And something else is true, that diagonals bisect each other. So A is the same length as 8. So A is the easiest one to find off the bat because, well, A is 8. The sides are a little bit different. They're expressions that I have to create an equation and then solve. So if they share the same tick mark or arc mark, they are equal. Therefore, 7x minus 17 is equal to 3x plus 11. And if you are to solve, we'll subtract 3x. We get 4x minus 17 equals 11. And then we'll add 17. And we're going to get 4x equals 28. And then our last step, divide by 4. So x is 7. Okay? On this one, I don't have to substitute in because I have opposite sides are equal. And if you notice, 3y minus 15 equals 2y plus 3. So they share the same variable, so I don't need to substitute in. And they have the same tick mark, so I can set them equal. 3y minus 15 is equal to 2y plus 3. We'll subtract 2y, and we get y minus 15 equals 3, and then we add our 15. So y equals 18. And we're done. Okay? You guys are doing great. The last one, we're to the last one. Yay! The perimeter of the parallelogram RISC, R-I-S-K, is equal to 54 centimeters. Segment RI is 1 centimeter longer than segment RK. Find the lengths of segment RI and segment RK. This one is a bit of a story problem, so it's a bit more complicated, but I think we can do it together. The important thing is that the parallelogram is number 10 on our geometer. So everybody go ahead and get your geometer out, and let's draw number 10. I'm going to zoom out so mine kind of looks a little bit nicer. It should look something like this. Okay, and let's go ahead and label it R-I-S-K. So, it tells me the perimeter is 54 centimeters. What does perimeter mean? Does anybody remember? It means all of the outsides added together. Well, that's still kind of confusing, right? Because all we know is that opposite sides are equal, but it doesn't actually give us any of that information in the directions. All it tells us is that RI is 1 centimeter longer than RK. So we don't know how big RK is. We're like, I don't know. So well, if you don't know, well, you just represent it with a variable. So RK is X, which then means IS is X because they are the same. And if RI is 1 centimeter longer, are we going to subtract or are we going to add 1 to X? We would add 1, right? So then it would be X plus 1, which then means that KS is X plus 1. Okay, I have a bunch of expressions now, and all I know is that all of them added together is equal to 54. That's the perimeter, right? So if you add up all your X's, I have 4 X's plus I have only plus 1 and plus 1. So I only have 2 extra numbers, and I know that equals 54 centimeters. And then I go to solve, so I would subtract 2, I get 4x equals 52, and then I divide each side by 4. So x is then 13. In the directions, it does say find the lengths of RI and RK. So I can't stop there. I do have to plug in. Okay, so we have RI is equal to, it's no longer x anymore. X is 13, so it's 13 plus 1. So RI is 14 centimeters. And then we have, it says find RK, right? So now I have RK, and RK is just X, so RK is 13 centimeters. And if you really want to check yourself, you could say, okay, well, I know this is 14, I know this is 13, and this is 13. Do they all add up to make 54? 13 plus 13 plus 14 plus 14. Yeah, it does. It makes 54 centimeters. So that is right down our alley. We did it right. Okay, we are finished with 6-1 notes. The back is your homework. Just to remember, or a reminder, that you do have to have these properties memorized by test day. And we try to do 1 to 2 pictures a day. So today was parallelograms. And we'll fill this out tomorrow. All right, see you guys.